Hello grade 10 students, welcome back. This is video lesson number 4 and I am Madhu Varke. We will continue with the chapter number 3, that is pair of linear equations. In this video class, we will learn a new method called as elimination method, which is also the most convenient and common method used for solving a system of linear equation in two variables. As the name suggests, this method involves eliminating any one variable from the equation. Let us go over the steps that we need to follow in this method. First, we multiply both equations or one equation by some suitable number to make the coefficients of one variable, either x or y, numerically equal, whichever is convenient and involves less calculations. Then we add these two equations or we subtract these two equations so that one variable gets eliminated. Let's say we eliminated x. Then the addition or subtraction of two equations will give us an equation in y. We solve this equation to get the value of y. Now to get value of x, substitute this value of y in any of the two original equations and solve. Sounds complicated, but it is the easiest method available. Let me illustrate with an example. (3x plus 4y equal to 10 and 2x minus 2y equal to 2). Let us solve this equation by elimination method. Remember, in the last class, I had mentioned that if the equation can be reduced before solving, we must do it. So the second equation here has a common factor 2. So we will divide the second equation by 2 to reduce it. So 2x minus 2y equal to 2. This equation we will divide by 2. So we get x minus y equal to 1. Let's mark this equation as 1. 3x plus 4y equal to 10. Let's mark this equation as 2. Now we have to make the coefficient of x in both the equations same, or we could make the coefficients of y in both the equations same. It is always better to add the equations to eliminate. So in this case, if I make the coefficient of y 4 in equation 1, then I simply need to add the two equations because their signs are different. And on adding, the y term will get eliminated. So multiply equation 1 by 4 and then add equation 2 to it. 4x minus 4y equal to 4 is our first equation. Rewriting the second equation as it is, 3x plus 4y equal to 10. Now we simply need to add. On adding, minus 4 plus 4 becomes 0, so the y term is eliminated. 4x plus 3x becomes 7x equal to 14. So x is equal to 2. This gives us value of one variable which can be substituted in either equation 1 or equation 2. So let's substitute this value in equation 1 because it seems simpler. So x minus y equal to 1 will be 2 minus y equal to 1. Rearranging the terms, y is equal to 2 minus 1, which is equal to 1. So x is equal to 2 and y is equal to 1 is our answer. Let us use this method to solve another set of equations. Writing these equations in their standard form, 3x minus 5y equal to 4. This is also a standard form where the constant is written on the right side. The second equation is 9x minus 2y equal to 7. Now, let's decide which variable we will eliminate. Before making the coefficient of the variable numerically equal, let us look at the sign. The sign of y term in both the equations is same. So, we will have to subtract these equations. If we look at the sign of x terms, both are positive. If we try to eliminate x, in that case also we will have to subtract the two equations. Now look at the numbers, that is the coefficient. If we make the coefficient of y equal, we will have to multiply equation 1 by 2 and equation 2 by 5. Then the coefficients of y in both the equations become 10. But if we multiply first equation by 3, then the coefficient of x in both the terms become equal, that is 9x. So that is a convenient method to multiply just one equation instead of two. So we will multiply equation 1 by 3 and subtract equation 2 from it. So the first equation becomes 9x minus 15y equal to 12. The second equation, copy as it is. Now leave some gap and then draw a line, because we are going to subtract these equations. To subtract, we will have to first change the sign of all the terms in the second equation. So plus 9x becomes minus 2y becomes plus 2y, and plus 7 becomes minus 7. Now let us subtract. 9x minus 9x is 0. Minus 15 plus 2y will give us minus 13y. 12 minus 7 will give 5. So y will be equal to minus 5 on 13. Now substituting this value of y in any one equation. So let's substitute in equation 1. Three times x is equal to 4 plus 5y. I have rearranged the equation. Now substituting value of y in the equation, 5 times minus 5 on 13 plus 4. So this gives us minus 25 on 13 plus 4. We are going to add these two terms. So 13 times 4 is 52, minus 25 plus 52 divided by 13. That is equal to 27 on 13. So x is equal to 27 divided by 13 into 3. On reducing, this becomes 9 on 13. So these are our answers. Here is another example with a slight twist. Observe the coefficients of x and y in two equations. What do you notice? Yes, the numbers are very big. Also, the coefficient of x in the first equation is same as coefficient of y in the second equation, and coefficient of y in the first equation is same as coefficient of x in the second equation. Now if we try to make the coefficients of y or x numerically same, we will have to multiply the first equation by 93 and the second equation by 144, then the coefficients of x will become same. But these calculations are too big. So to avoid such calculations, we will use a method which can only be applied when the coefficients are arranged in this manner. Let's mark these equations as 1 and 2. We will first add the two equations. On adding the two equations, we get 234x plus 234y equal to 234. So there is a common factor dividing the whole equation by 234. You get x plus y equal to 1. This is our reduced equation. We'll mark this as 3. Now subtract both equations. So rewriting the equations, when we subtract, we change the sign of the terms of second equation. So here this becomes minus, minus and minus. So 141 minus 93 is 48x. Over here minus sign is with the bigger number, so you'll get minus. Since we are subtracting same numbers, again we get 48y equal to 144. Now find the factor by which you can divide this equation. We can divide the complete equation by 48. So we get x minus y, and 48 3 times is 144. So we get here 3. So this is another equation. We'll mark this as 4. Now we need to solve these two equations using elimination method. So rewriting the equation, x plus y equal to 1, x minus y equal to 3. We just need to add these two equations because the sign of y terms in both the equations are different. So on adding, y gets eliminated. You get 2x equal to 4 or x equal to 2. Now we can substitute value of x in any one equation. So let's substitute in the first equation. X plus y equal to 1. So y equal to 1 minus x. This is equal to 1 minus 2, which is minus 1. So y is minus 1 and x is plus 2. We will now solve a word problem on 2-digit number. The sum of digits of a 2-digit number is 9. 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. Let's understand this problem by taking a random 2-digit number, say 48. 48 can be written as 4 times 10 plus 8 times 1. So the digit in the tens place is 4 and digits in the ones place is 8. In this example, to find the 2-digit numbers, we will have to first find each digit. So let the digit in tens place be x and digit in ones place be y. So our 2-digit number can be written as 10 times x plus y. The first sentence says the sum of the digits is 9. So x plus y, only the digits, not their place values. So sum of the digits is equal to 9. This gives us our first equation. The second sentence says 9 times this number is twice the number obtained by reversing the order of the digits. So let's find what number we get on reversing the digits. X goes to ones place and y goes to the tens place. So this becomes 10y plus x. This is the number that we get on reversing the digits. According to the question, 9 times this digit, that is 10x plus y, is equal to 2 times the number obtained by reversing the digits. So the number obtained by reversing the digits is 10y plus x. This is our second equation, but we need to reduce it into the standard form. So 90x plus 9y is equal to 20y plus 2x. Taking all terms to the left side, all these are variables. So 90x minus 2x plus 9y minus 20y is equal to 0. So we get here 88x minus 11y equal to 0. We can reduce this equation. This becomes 8x minus y equal to 0. So this is our second equation, and the first equation was x plus y equal to 9. Now we can solve these two equations using elimination method. We can add these two equations. I am quickly going to show here. 9x will be equal to 9 on adding the two equations because y will get eliminated. So x will be equal to 1. Substituting value of x in the first equation, we get y equal to 9 minus x, that is equal to 8. Therefore, what is our number? 10x plus y, that is 10 times 1 plus 8, which is equal to 18. So this is the number that is asked in the question. Try solving this word problem. Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. We have to find out the number of notes of 50 denomination and 100 denomination. So these are our unknown quantities. Let number of 50 rupee note be x and number of 100 rupee notes be y. Meena got 25 notes in all. This gives us our first equation. So there are some 50 rupee notes and there are some 100 rupees note. Together there are total 25 notes. So x plus y is equal to 25. Mark this equation as 1. Now she withdraw rupees 2000 in all. So counting 50 rupee note, the sum of money is 50x, and counting 100 rupees note, the sum of money will be 100y. On adding these two, you get the total money she took out from the bank. So we get our second equation, but we need to reduce it. So we can divide throughout by 50. So x plus 2y is equal to 40. This is our second equation. Now I leave the solution part to you. Use elimination method and solve it. Now try to form equations for this word problem. A lending library had a fixed charge for first 3 days and an additional charge for each day thereafter. Sarita paid rupees 27 for a book kept for 7 days, while Susie paid rupees 21 for books she kept for 5 days. Find the fixed charge and the charge for each extra day. Let the fixed charge be x and the charge for each extra day be y. She pays 27 rupees for keeping the book for 7 days. So, out of 7 days, the cost of keeping the book for 3 days is calculated as x, because this is a fixed charge for 3 days. Then the remaining days, that is 4, is charged at y per day. That means the total charge for 4 days will be 4y. So with this we can get our first equation. X plus 4y should be equal to the total charge she pays. This is our first equation. Similarly, Susie paid 21 for book she kept for 5 days. Out of 5 days, 3 days will cost rupees x and remaining 2 days will cost rupees 2y. So x plus 2y will be equal to 21. This is our second equation. I leave the part of finding solution to you. Use elimination method and solve it. With that, we come to the end of today's video lesson. This is your assignment, exercise 3.4, question 1 and question 2. In next video lesson, we will learn about a new method, that is cross multiplication. Goodbye.